I am absolutely thrilled about what we're digging into today. We're going to trace the wild, totally accidental history of an everyday medicine that's probably sitting in your bathroom cabinet right this very second. Seriously, it's a story that kicks off with a genuinely gross medical mistake, takes this terrifying detour through a highly colorful side effect, and then wraps up as a massive multi-billion-dollar modern mystery. So get ready, because the evolution of Tylenol and paracetamol, yeah, it is anything but a standard scientific process.
Picture this. It's the year 1884. The Washington Monument has just been completed, and honestly, the world is generally a pretty disgusting place filled with mysterious diseases that doctors, well, they just don't understand yet. Now, over in a hospital in Germany, there's this patient suffering from intestinal worms, a problem that is exactly as gross as it sounds. To treat this poor guy, two physicians, Arnold and Paul Heep, decide to try out a chemical called naphthalene. So they write up the order, send it off to the pharmacy, give the resulting medicine to the patient, and then they just wait to see what happens.
And this brilliantly illustrates exactly how different 19th century medicine was from today. You see, the pharmacy didn't actually send them naphthalene at all. No way. Back then, pharmacies didn't just sell medicine in neat little blister packs. They were active research labs that also sold industrial chemicals. In a massive mix-up, the pharmacy had accidentally sent the doctors acetenolide, which is a chemical basically known for making industrial dyes. They essentially just fed their patient a fabric dye.
So what exactly happens when you give a patient with worms a chemical meant for coloring textiles? Well, the good news is the worms are completely fine. They are having a great time, totally unbothered. But the weird news? The patient's fever, which, by the way, the doctors weren't even actively trying to treat with this specific drug, well, that fever completely vanishes. Suspicious that their medicine was cut with something else, Doctors and Heep head straight back to the pharmacy and discover this monumental mix-up. They realized they had accidentally stumbled onto a highly potent fever reducer. Section 1. The Blue Skin Disaster, a mega-busted side effect.
So the doctors immediately pivoted and started selling this chemical as a fever reducer under the very catchy name Antifebrin. But they were about to hit a terrifying problem. Because remember, Antifebrin was a chemical meant for coloring fabrics, not human beings. And that brings us to an absolute beast of a word. Methaglobanmia. Look, just looking at it is frustrating, right? But I promise you, it is far worse to have than it is to pronounce. Methaglobanmia violently messes with your red blood cell's ability to carry oxygen throughout your body. And when your blood isn't properly oxygenated, well, things start to go sideways very fast. Specifically, your skin, your nails, and your lips turn bright blue. We're talking about a full-blown blue skin disaster. It was dangerous, it was deadly, and honestly, aesthetically speaking, it was not ideal for anyone trying not to look like a cartoon Smurf.
Section 2. The birth of Tylenol, finding the real magic bean.
Okay, let's dive into this. Suddenly, the medical community is in an absolute panic. The race is on to find a version of this fever-reducing magic bean that killed pain and lowered temperatures, but, without turning the entire human population into Smurfs. They needed the benefits of the dye chemical without the suffocating blue-tinted disaster. Looking at the timeline of how they solved this, we start with our 1884 pharmacy mix-up. Then, just 3 years later, in 1887, researchers come up with two promising alternatives, phenacetin and acetaminophen. But look at this gap. For decades, the medical community completely ignored acetaminophen. Why? Well, because they were absolutely terrified it would still cause that blue skin methaglobanmia. So they heavily favored phenacetin, right up until 1947, when it was definitively linked to severe kidney problems. They were literally running out of options.
But here is the incredible, almost hilarious scientific twist. When scientists finally took a closer look at acetaminophen, they realized a massive joke had been played on them by human biology. Whenever patients took the dangerous blue skin-inducing acetenolide or the kidney-destroying phenacetin, guess what? Your body was immediately converting it into acetaminophen anyway. Acetaminophen was the safe, active part doing all the heavy lifting the whole time. Finally realizing this, the pure, safe drug hits the market in 1955 under a name you definitely know, Tylenol. It promised to kill your pain without ruining your kidneys or turning your lips blue.
Section 3. The Modern Medical Mystery, a Logistical Stalemate.
Which brings us to the present day, and honestly, this is where things get a little mind-bending. We've solved the blue skin problem, but we've stumbled right into a completely different kind of paradox. Let's look at the sheer scale of what this accidental worm medicine has become. $9.5 billion. That is the size of the global market today for this accidental discovery. From a mistaken order of industrial dye in a German hospital in 1884 to a nearly $10 billion economic titan.
And that massive market builds on another staggering metric, 600. Today, acetaminophen isn't just Tylenol, it's an active ingredient in over 600 different medicines globally. It's ubiquitous. It's in cold medicines, flu remedies, sleep aids, you name it. It is practically a foundational pillar of modern over-the-counter medicine.
So the crucial point here is that we're essentially living in a logistical stalemate where we literally don't know exactly how it works. Yes, you heard that right. As of right now, despite it being in over 600 medicines and generating billions of dollars, science literally doesn't know the exact mechanism of action for acetaminophen. We take it for granted, yet its inner workings remain a closely guarded secret of human biology.
Now, we aren't completely in the dark, but we are definitely relying on educated guesses. The leading scientific theories suggest it might tell your brain to stop cooking up what scientists lovingly call ouchies. The actual scientific term is prostaglandins. Or maybe it only operates in the central nervous system because it needs an environment with low peroxide to function. Another theory is that it toys with your neurotransmitters, or perhaps it interacts with serotonin, the happy hormone. But at the end of the day, these are just theories. The only thing we know for absolute certain is that it's safe, it reduces fevers, and it definitely won't turn you blue.
Which leaves us with this final lingering question. After over a century of use, starting from a botched pharmacy order all the way to becoming a staple of human health, how does this magic bean actually work? It's fascinating, isn't it? To realize that sometimes the most common things in our lives are hiding the deepest mysteries. Next time you take a pain reliever, just remember the worms, the industrial dye, the blue skin, and the fact that you are swallowing a tiny, modern enigma. Thank you so much for joining me for this explainer. Keep asking questions, and I'll catch you next time.